Don't you just hate it when you have to make little parts like this one or even smaller, and you blacken them to draw your outlines, and every time you try to draw a line, your ruler is trying to escape, and the scribe you use is trying to roll away, so you never have this precision drawings on your part. Now, there's two ways to fix the problem. Way one, you don't make outlines, or way two, do something about it. The ideal, of course, should be to use a nice and square block. Put my part square against this block and then use a scribe gauge or a height gauge or something with this idea. Like this and like this. So, because I don't have, I'm gonna make one. We're getting somewhere. I'm gonna use this block as a base. Of course, I'm gonna clean it up in the shaper. And for a while now, I have this cheap, crappy calipers. I never really trusted it. It works, but you can feel it's not a good one. And I already started to take it apart. Here's the little parts. And my idea is to, I'll take it apart first, turn it off, cut off this leg and see if there's a system I can find to mount it here in this block. And then, of course, mount this one back in here, nice and square, which means I'm gonna have a height gauge with DRO. These two parts here, I just gave it a little touch with a file, and this steel is not hardened. Now, when this gauge system will go to 0, this plastic thing here is in the way. So my idea is to use a little piece of high-speed steel and mount it here. Of course, I'm gonna cut it off, it's way too long. Mount it here. The problem is this one is 3 millimeters and this one is 2 millimeters. To hold this one in place, the idea is to make a slot and then drill 2 holes here, drill and tap, and then put bolts in, and these 2 bolts gonna push against this part. Of course, gonna be at 0 height, and this one I'm gonna cut off. That's about the idea. Let's see if it works. But first I'm gonna clean up this block and try to make a 3 millimeter slot in it and see what happens. For this part, the absolute precision is maybe not really necessary, because we're not gonna use the sides to draw lines. It's just the part of the calipers must be nice and square in it. So to clean it up, I'm gonna put it this way in the vise, so I can clean up this surface and this surface in one setup. Which means I cannot put it on parallels, otherwise my cutting tool gonna touch the parallels. So I'm gonna take it out again, put the parallels away and just use a little block like this. It's gonna serve me as a parallel. Put my part in, protect the vise with a little bit of belt sandpaper things. Gives me additional grip on the part also. Just like this. Tappy tap tap. No, that's another YouTube channel. great. Last week there were a few questions about this frequency drive system. Now, one question was, could it be useful to put an emergency stop on the system? Now, of course, I'm always a fan of safety first. I think an emergency stop can even find its place in your pockets, but it must be useful. If I put the emergency stop right here next to the frequency drive, I think it's too far away. It should be a logical place, but it's too far away. And I don't really see the need, because when you operate the shaper, you're always sitting or standing on this side, because here is the table movement system. The zeros are here on this side, on the other side there's no. And here you have the clutch system, you can always operate, and the electric switches. So emergency stop, I don't see the need. If something happens, you have the clutch system, and you have the switches here. What I had a few times without knowing it, I bumped with my knee against these buttons and the shaper stopped, and I was wondering why. Just bumping the buttons, they're right here. Shit happens. Because this bigger surface is gonna slide on the surface plate, I would like to have it a really beautiful finish. So I give it a touch with the shear tool. Last week there was also a question from David, and David, he's asking me, when do we use the clapper and when do we lock it? Well, David, I think that is a very interesting question, because if you're not every day in this machining things, of course you don't know, and there's absolutely nothing wrong with I don't know. Just ask. Never be afraid to ask. Okay, let's go for it. This clapper now for the moment is completely free, and what happens with the law of inertia, we can ask Newton for a little bit more explications. The whole thing is jumping. The problem is, of course, this is a bit violent, and if you do that for a few hours, something will break, that's for sure. And that's why I made myself this beautiful little knob and a spring. And this thing is gonna limit the movement of the clapper, but still free, can move. And why is it movement so important? On the cutting stroke, this whole table, the part, the ram, this all combined systems, there's always a flex in it. Every metal is flexible. So this machine is flexing a little bit, and you can see in YouTube videos from some other creators on the lathe, when they take heavy cuts on the lathe and then turn back. Normally it should not cut anymore, but then you see the line. That's why the clapper must always be free to move, because the cutting tool will push into the part, and then we're gonna chip off the cutting side. Now, in some cases we do not use the clapper. For example, when we use this one, this slotting bar goes in here, the cutting forces of course are going backwards, but also a bit down. So during the cutting stroke, this whole bar is tended to lift, if it lifts the clapper, of course, it will not cut anymore. That's when we lock the clapper, and the flexing of the bar will take the difference of height. Of course, at this moment it's very important to feed down at the moment that the cutting tool is out of the workpiece on the back side. I think that's logic. Now, another situation when we lock the clapper is when we do undercuts. Let's go to the blackboard and have a look at that. For example, whatever thing, this is the part I have to cut. Like this. If the cutting tool is cutting right up here, no problem. Okay. The clapper box is lifting, so the tool is free from the cut surface. So it means if any chips or whatever junk is left on the surface, the tool will lift up and no problem. If the clapper is locked and the tool is touching a chip or whatever shit that's laying around on the finished surface, it's gonna break the tool, because now of course the tool is cutting out of a blackboard into the camera and the backstroke in the other way. If now we have to work this surface, it's perfectly possible on a shaper, not a problem. Of course, if now the tool lifts, it's gonna dig in the workpiece, and that's when we lock the clapper to be sure the tool is not lifting after every cut. Here also we feed in that way after the cut is finished, at the end of the backstroke. Now I'm gonna cut the groove that comes in the middle of the part that's gonna hold, of course, this thing, this way, in place. And I would like to have it square. Now if I cut it out by hand, it will never be square. If I cut it out on the shaper, there will be so much tool stick out that the tool is gonna break, it's never gonna work. So what I come up with is this idea. Let's see if it works. I think my angle grinder idea was not too bad, it seems to work. It's just one little problem. I think with the flexing of the grinding disc, you'll see that here it will enter, but not all the way. I suppose it's the disc that's searching a bit left and right. But about that, I think it looks good. So I'm gonna touch it off a bit with a file and make this thing fit in here. Indeed, I said file it out, give it a little touch with a file. I didn't say hand filing. Hand filing, I think that's for primitives. Okay, I think this is more or less the fit I'm looking for. There's a little bit of play here, but that will be okay. Now, if there's too much play, I can always put some shims between this part and the inside part here. But we'll see. Let's drill and tap these two holes to make the spanner system idea to hold this thing in place. That seems to work. This week I received some other electrical questions which I'm gonna try to answer currently. Now, here in the region where we live, the standard is 220 volts single phase. That's what you have in the houses. You can ask if you have this electrical heating system or for the cooking plate for the kitchen. You can ask the electric company to receive 3 phases, and then depending of where you live, it's 3 times 220 volts or 3 times 380 volts, and all this is of course 50 Hertz, frequency of 50 Hertz. Where I used to live before, we had 380 3 times. Where I live now, it's 3 times 320 volts. I'm not gonna dig in too deep in it because it's everywhere a little bit different, except here it's the same. Now, if you buy a machine, and especially if it's a bit older machine, it's professional equipment, and most of the electric motors are 3-phase. So if you ask 3-phase, that's not a problem, but if you don't have 3-phase, what you can do is use the variable frequency drive, or the VFD. What it does, you have 1 times 220 volts, and it makes 3 times 220 volts. Income is of course 50 Hertz, and comes out whatever you want, because you can change it. A question was also, is it possible to put a VFD on a 1-phase motor? But of course, sometimes in these small machines there is a frequency drive. There's 2 options. I'm gonna take this away. If you enter 1 time 220 volts, and this thing is the VFD, okay, goes out 3 times 220 volts. If you use only 2 phases of the 3, you have 1 time 220 volts. Now there also exists, same system, is the VFD, 1 time 220 volts, 50 Hertz, and comes out single phase, 1 time 220 volts, and of course the variable frequency, which is really handy if you have a drill press like this one you see behind me. This one is a single phase motor, and you're tired of changing belts every time. You put a VFD like this one, is really cheap, and you can change the rotations per minute on your motor. Now, one thing you have to keep in mind, the lower the frequency, the lower the torque on the motor, and it makes more heat. If you put your frequency drive on 0 Hertz, the motor will not spin, and it still will continue to consume this amperage. So the energy will be transformed in heat and not in torque. Beware of that. The problem is now that this little jar here, when I put it completely down, of course it doesn't touch the surface. So what I plan to do, I put this in place at 0 if it wants to, of course, and then make a little plate that's gonna hold this part and that I can bolt down on the calipers. I think it looks typical self-made, but I suppose that will do. I'm gonna reassemble the thing and then bring you back when everything is together and see if it works. And this is what I had in mind. Now let's see if it works. Let's say on this part I want a line at 10 millimeters. So I take my brand new toy here. First of all, put 0, 0, 0 again. Yeah. I'm doing this with my left hand, it's not really easy. Not easy at all. Can we agree that this is 10? It's 10.01. I think that will do. It works! I think it was a nice little project to work on. The result, I think this will work. Of course, you can see it's a self-made thing, but for me, that's okay. And now you're gonna tell me, haha, but he doesn't have no calipers anymore. I bought a brand new one.